right, so if you look at this graph here, you can ignore all this stuff here, but we've got this blue curve, and then the orange line is what kind of line? Secant. And the black line is tangent. Okay, so between these 2 points, there is, and so if I have these 2 orange points, I can find the average rate of change between those 2 points, right? And I can move this black, oh, don't do this to me. Apparently I can't with this board being touchscreen makes some, oh, good Lord in heaven. Okay, let me get back there again. Because I know I can do this. Oh, no, I guess I can't on this. It's here. Good. I thought it was my board. I can move this to where they're parallel, right? And I kind of showed you with my bad pictures about that's why there's at least one, there is exactly one on this graph, one place between these 2 orange points where the instantaneous rate of change is the same as the average rate of change, right? That's the whole idea of MVT. So I want to show you some of the when they don't work situations. Okay, for instance, this one. This was that x to the 2/3 power. Remember that little graph I drew you? And so between these 2 points, because remember there's 2 things that have to be true. It has to be continuous. My blue function is continuous, but it also has to be differentiable. And it's not differentiable here, right? So when I take this black line and I move it, you see how there's no time where it's going to be parallel to that orange line because of that cusp there, since it's not differentiable. Okay, so that's one of the reasons it has to be differentiable. And then, but then look at this one. There's a time here, right? So the whole function doesn't have to be differentiable. It has to be differentiable between those 2 points. Okay, so that's why when we took that derivative on one of the first questions that we did, I think it's this one that I have open, so let's look at that. I think it was here. Yes. It was this one, where we ended up with the x squared in the denominator, and I asked you, like, we can't see it, but between 1 and 5, I can substitute in any number 1 through 5, and the derivative gives me a number. If I substituted in 0, then it would be undefined. So it's not differentiable when x is 0, but we were okay on this one because of that interval. We were not okay on the next one because the interval was different. So same graph, but it works here, but that's because where the points are, right? So that's why you're looking at that, in that interval, is it differentiable there? We don't care if it's differentiable the whole time. And then, so this one is a little bit kind of harder to see, but you see the little blue pieces there? It's a piecewise function. So it's not continuous, right? So not continuous between those 2 points. So when I move this and it jumps, you see how that black line is never going to be parallel to that because it's not continuous because we're jumping around. Okay, so I just thought this was some good visuals of why some of those didn't work. All right, so let's go back here to where I told you we're going to start. Let's talk back through this since it's been a couple of days. So we should already have this stuff written down, hopefully. But we have the table below gives the values for the particles. So we have the position at x of t, the velocity, the acceleration, and it says a of t is continuous for all real numbers. So if a of t is continuous, then the rest of those above it have to be continuous. Okay. And then we knew that v of t is like the derivative of the position. A of t would be the second derivative. So just different ways to look at that. So it says, is there a time that tells me it's either MVT or IVT, right, where A of C is equal to -2, okay? So, do you think this is IVT or MVT or either one of them? Are we looking for something that's possibly missing on the table? Yes. Could we look at this from an average rate of change position as well? Okay. So if A of C is -2, it would have to fall in between here, and it says when C is 2 to 3, right? So would it make sense that that would work that way? Okay, so can I find A of 1, no, A of 2, and A of 3. What is A of 2? Negative 3. What is A of 3? Negative 1. Okay? And then I can say negative 2 is what? Between negative 3 and negative 1, or it doesn't really matter what. All right, and then justify my answer. What would I need to say? What has to be true if I'm using, which one is this? Did we even say, is it IVT or MVT? This one's actually IVT. We could have done this problem as MVT as well, but do you think IVT is a little bit easier? Yeah, I'd go with IVT if I could choose it, because it's a little bit more, ooh, I got A, it's in between, you don't have to say anything else. So what's the only thing that has to be true for it to be IVT? Continuous. Is this continuous? Yes. How do we know? It tells us right there, right? So then we can say, since A of t is continuous, there is a time, where am I getting these words from? The question. C4 to C3 such that A of C equals -2 by IVT. Or I could have said that IVT guarantees that blah, blah, blah. Okay. What questions you got? All right. I at least wanted to do this since we had started this question. I wanted to finish it. But do you have any questions overall for MVT or IVT? Do we understand how to find figure out the differences? I feel like we did quite a few examples yesterday. I don't want to example you to death. So instead, I would like for you to take this time to work on the assignment that I gave you. It has all those multiple choice questions on it. So get that out and don't give me dirty looks. I see you side-eyeing me.